We're going to take a couple minutes to explain the differences between traditional ultrasonic thickness testing and ultrasonic localized guided wave. What we've got here is two samples of pipe. One is a good piece of pipe, which is filled up about to the tape here with water. You can kind of see inside here that I got water in the pipe. This one, exact same type of pipe, both 4-inch Schedule 10 steel fire sprinkler pipe. This one obviously is corroded on the inside. So what we're going to do is start off with thickness test. What we've got here is a standard thickness gauge. Putting a little bit of couplant on the probe. Couplant kind of acts like the same jelly they use for a woman's ultrasound. It helps create a good seal between the transducer and the material that we're measuring. And what I'm going to do is just hold this up against the pipe. You can see here that this is measuring at 120 thousandths, which is exactly at nominal for this size pipe. I move around a little bit, 120, 121. Now I'm going to move the probe down to the lower half of the pipe where the water is, and you're going to see it's the same measurement, 120 thousandths. Important thing to note here is that the measurement is exactly the same between the wet and the dry side, which it should be because that's the wall thickness on the pipe, but you can't tell the difference between where there's water and where the pipe is dry. So now what we're going to do is run the same scan on our corroded piece of pipe. Put the probe on here, and you're going to see here that this thing really jumps around when I move the probe around, and depending on where I put the probe, I can get a measurement of, here's 118, 117 thousandths, which is very close to nominal. Let's see, I'll float around this thing a little bit here. And here's a spot, here we're at 39 thousandths, so that's a little over 2/3 wall loss that we're finding now on this pipe. But the important thing to note in regard to that is, as you can see, we really had to hunt around to find that specific area. So to really do an effective scan with this equipment on a large system would require sliding this transducer head over all of the equipment throughout the facility. So now we're going to run the same scans using localized guided wave. We're going to go back to our good piece of pipe. We've got our localized guided wave scanning head, same couplant. What you're looking at on the screen there is the upper signal is what a perfectly good Schedule 10 4-inch diameter pipe waveform should look like on a dry pipe. We'll do a scan here, and as you can see, the waveform that we're measuring on the bottom exactly matches the one on the top, where it's really close. So the important thing is that the waveforms look similar to each other. This would indicate a good dry pipe. So now I'm going to move down to where there's water. Let's pretend that there's water that's trapped inside your dry pipe system. Here you can see that there is a significantly different type of waveform here. And what's happening is some of the sound energy that normally travels through the wall of the pipe is leaking into the water inside the pipe, which is indicated by those second set of waveforms there that are not present on the upper signal. That energy tells us that there is water inside that pipe, which is a good thing in a wet pipe system, but in your dry pipe system, you don't want to see that. Conversely, we can also find air pockets that are trapped in wet systems using the same thing, just flip-flopped. So now we're going to run our scan on the corroded piece of pipe. By the way, this corrosion is one of many different types of things that we can find with this technology, but it's just for an example here today. As you can see from this, there's a little teeny blip where the first pulse of sound energy is. The rest of it is a flat line. What's happening there is the corrosion inside of this pipe is absorbing all of our sound energy. It gives us a very clear indication that there is some severe corrosion present inside that pipe. So when we're out testing in the field, we would then follow up with the thickness gauge in those areas and really hunt around and look for the absolute worst spots to tell you how bad the worst areas are within your system. It's a very effective and accurate way to determine corrosion issues inside your piping systems. That's about it. Thank you.